We now write the polynomials f of x and g of x such that the graph of y equals f of x over g of x has the following characteristics. That is, the graph of y has vertical asymptotes at x equal to -2 and x equal to -5, and horizontal asymptotes at y equals -3. So first, let's consider the vertical asymptotes. We have vertical asymptotes at x equals -2 and x equals -5. We say that for a rational function, the vertical asymptotes usually happens when the denominator equals 0. So considering this as the vertical asymptotes, I add a 2 on both sides. So when I do that, I get x plus 2 equals 0. And so this is one of the factor which makes the denominator equal 0. And similarly, for the other vertical asymptotes, that is x equal to -5, if I add 5 to both sides, we get this equation or this linear term equals 0, that is x plus 5 equals 0. So this is another factor which makes the denominator equal 0. So we consider the product of these two as g of x. So therefore we can write the g of x, and this equals x plus 2 times x plus 5. So now we can write y as f of x over g of x. So therefore y equals f of x. We now replace g of x, that is x plus 2 times x plus 5. In fact, we can FOIL these two and give it in a quadratic form. So when we FOIL these two, we will get x squared plus we take the sum of these two numbers, that is 7, and then put this as 7x, and we also take the product of these two numbers, that is 2 and 5, which is 10. So when we FOIL these two factors, we will get x squared plus 7x plus 10. Let me write down here. So we say y equals f of x, and this is over x squared plus 7x plus 10. Now we are going to use the other information, that is horizontal asymptotes is at y equals -3. So when we are finding the horizontal asymptote of a rational function, we always consider the highest degree of both the numerator and denominator and then divide their coefficients. Suppose if we have ax squared divided by bx squared, and we can have any other terms here, like this can be cx plus t, and this can be here, let's say kx plus m, anything after this. And when you are finding the horizontal asymptotes, we just have to look at the degree of the numerator polynomial as well as the denominator polynomial, and they should be the same. That is, here it is x squared, and we say that a by b is the horizontal asymptote. So likewise, we are already given that horizontal asymptote is given as y equals -3, and this means the degree of the polynomial has to be x squared, because in the denominator we have x squared. So let's put x squared, and we can put any other term here, and we'll put this denominator now x squared plus 7x plus 10. But however, when we divide this coefficients, that is, let's say this is a and this is b, a by b should be equal to -3. A by b should equals -3. But we already know the coefficient of the denominator polynomial, that is b equals 1. So let's substitute b equal to 1 here. And when we do that, we get the value of a, and this equals -3. So this is how we determine the coefficient of the x squared. So we can put -3x squared, and we can put any other term in terms of decreasing powers of x, like we can put 2x plus 5. This is one type of polynomial, and the denominator polynomial is x squared plus 7x plus 10. The most important thing is that it should be of degree 2, that is, it should have a x squared term. The highest degree term should be x squared, and its coefficient should be -3. So this is the most important thing. And so this is one such example for f of x. We can have another examples for f of x, like I can give like negative, just negative 3x squared also, or we can also have f of x equals negative 3x squared minus 5, something like this. So it does not matter here. So let's say that one such f of x is, you can say that negative 3x squared plus 2x plus 5, and the denominator polynomial, that is g of x. And so this equals x squared plus 7x plus 10. So this is how we have determined that f of x and g of x